Alright, so first we have to show that this hyperbola can be described by x equals ct, y equals c on t. So if we first take x equals ct and make t the subject, we have x on c. If we sub that into y, we would have y equals c divided by t. So we're timesing by the reciprocal of t, 1 on t. So we'll reciprocate, and you see you get c squared on x, or if I times you get xy equals c squared. So yes, these are parametric equations, no problem, for the hyperbola xy equals c squared. If we differentiate parametrically, we know that x equals ct, so dx differentiated with respect to t is c. We know that y is ct to the minus 1 in index form. So do y with respect to t, differentiate with respect to t, we get minus ct to the minus 2. So if I'm looking for dy dx, then I can use dy dt times dt dx, because these dt's will cancel. So dy dt is minus ct to the minus 2, or actually I might put it t squared on the bottom there, so get rid of that. And multiply by dt dx, which is just this upside down, so that's 1 on c. So you can see the c's cancel, we get negative 1 on t squared. So our gradient at the point ct, c on t, is negative 1 on t squared. So now if we wanted to find the equation, we would go y of this tangent, y minus y1, y1 and x1 coming from here. So y minus y1 is gradient, so there's the gradient, x minus ct. So if I make y the subject, we've got minus x on t squared, then we've got negative negative, so we've got plus c on t, and then we're adding this c on t, so we've got plus 2c on t. So that's our tangent equation at t. And so we also have to prove that, okay, so we have to prove the x-intercept. Well, let's find, how do we find the x-intercept? To find the x-intercept, we make y equals 0. When y equals 0, we will have x on t squared equaling 2c on t. So that means x equals 2c on t times t squared. One of those t's will cancel, and you can see you get 2ct. So if I were to write the points of interest here, the points of interest, we've got t, ct, c on t. We've got the a now. So a is this x-intercept, which is 2ct 0. And we've got the origin. Alright, so we've also got the origin, which is, of course, 0, 0. So we're supposed to show that it forms an isosceles triangle. So actually, if you can kind of see that OT, well, let's say OT squared, so we don't have to do square rooting. From O to T, you can see that would just be CT, so the x value squared, and the y value squared. And if I look at OA, that would just be 2CT, that would be the distance. So I know not to look at that one, so I'm going to look at TA, or AT, it doesn't really matter. So AT squared, so I don't need to put the square root, again using Pythagoras. So the x's, so we've got 2ct minus ct squared, plus c on t minus, or 0 minus ct squared, same thing. So you can see we still get ct squared, and we still get c on t squared, because negative times negative is a positive. So we know that ot squared is at squared, as in that distance and that distance. Therefore ot equals at, and therefore it's an isosceles triangle. You could find the third side and see, you could find OA, and it's very clearly the distance is 2ct, so it's got to be isosceles. Alright, I hope that helps.